Differentiation rules. We're going to specify how to take different derivatives without doing limits. Yay! Alright, dy dx, that's a noun. That means this is the derivative of y with respect to x. D dx is a verb. It means take the derivative with respect to x. Alright, we have the constant rule. This one's very easy. If you have a constant function, for example, let's say y equals 4, if we graph that, it would look like this. So the slope of that is always 0. So find the derivative of the following functions and practice using the different notation. This one would be 0. dy dx equals 0. This one we could change it up and write f prime of x equals 0. S prime of t equals 0. Oh, and k is a constant, pi is a constant, so dy dx is 0. The slope is 0. That's a very easy rule, one you should definitely remember. Now this is a powerful rule, okay, also known as the power rule. This one we've noticed before, if we have something like 3x squared, the derivative is going to be 6x, because all you do is you multiply this, the constant, and the power, okay, and then subtract 1 from the power. That's what that's saying. So as you try to do these, we have f prime of x, multiply the 3 times 2, you get 6, and then subtract 1 from the power. So we get 6x squared. Alright, let's try the next one. Oh, I don't like the way that looks. I'm going to rewrite it. I'm going to write it as 1/3 x. Now, instead of writing cube root, I could write 1/3 power. Alright, this makes it a little easier to use the power rule. 1/3 times 1/3 is 1/9 x. Now subtract 1 from the exponent, negative 2/3. If you don't like how that's written, you can change it. Okay, we could write it like this. You can also write it as x squared, the cube root of x squared. Alright, let's rewrite this now. I'm going to rewrite it as 5/3 times x to the negative pi. So y prime then is going to be negative 5/3 pi times x to the negative pi minus 1. Not bad, but it's a problem here, okay? And now this one, I'm going to help you rewrite it. Y equals, we can write it as 6 times x to the negative 3/5. So that's one that I would like you to go ahead and write in your WISP. Write the answer of that. Okay, moving forward, we have another example of when this might be useful. Now I'm going to go ahead and rewrite this. F of x equals 1/2 x to the 4th. Find the slope of the graph when. Alright, so let's get our slope function. F prime of x equals 4 times 1/2 is 2. X to the 4 minus 1 is 3. Now we have our slope function, so we just plug in each of these numbers. Alright, f prime of negative 1, plug that in, you should get negative 2. F prime of 0 equals 0. And f prime of 1 equals 2. So there you go. That's really easy once you have a slope function to plug it into. Alright, now we're building here. Find the equation of the tangent line and the normal line to the graph when x equals negative 2. So if this is our function, let's get our slope function. F prime of x, 3 times 2 is 6. X to the, subtract 1 for the power, that makes 1. So we're going to find the tangent line. So what is the slope when x equals negative 2? The slope is negative 12. We need a slope and a point for a tangent line. Plug in negative 2 squared, that's 4, times 3, so positive 12. So we get y minus y1 equals the slope times x minus x1. And we could write it as simply as this. Okay, if you want to write it using slope-intercept form, go ahead, but I'm not going to. The only thing that's going to change for our normal line is our slope. Our slope is now going to be positive 1 over 12, and our point is still negative 2, 12. Now instead of writing y minus y1, I'm just going to go ahead and move that y value over. Okay, just like I did, I'm just saving myself this step. Okay, minus, oh, it's plus actually because it's a positive slope, x plus 2. Alright, I just noticed a mistake. Why did I put minus 1? It should be plus 2 there. Wow, that could have been a big mistake. Alright, so I fixed that. There we go. And now we have part C, find the other point where the normal line intersects f of x. Alright, so we have our normal line. Maybe it won't be as helpful to have it in this form. Maybe it will. We're not sure. Okay, so I'm going to just start out with that. Where does this normal line, where's another point where it intersects this graph? Alright, I don't like fractions. Actually, I really do like them, but I'm going to get rid of them anyway. So I'm going to multiply both sides by 12. Okay, so I get 144 plus x plus 2. And 3 times 12, 36, x squared. I'm going to pull everything to one side. 36x squared minus x minus 146 equals 0. Now from here, if you're really good at factoring, you can factor, or you can use the quadratic equation. 36x, okay, x plus 2 minus 73. I believe that works. You can check it out. So we'd have at x equals 73/36, or at x equals negative 2. Since we're trying to find the other point, we have this value right here. Now the problem is that's not a point, okay? A point has an x and a y value. So we have 73/36, but we also need the y value. So in order to get that, you'd have to plug it in. 3 times 73/36 squared. Obviously, that's 5,329 over 432, I think. Okay, so there you go. Not too bad of a problem. And we're going to keep seeing more and more of these. You'll see them on your worksheets. You'll see them on your quizzes. You'll see them in May. Okay, you're going to see them all year long. So let's move on to example 5. Find the coordinates where this function has tangent lines with the following slopes. So what that's asking us is to basically find the derivative and then see where it has each of these slopes. So what is the derivative function? If f of x equals negative 5x squared, then f prime of x is going to be equal to negative 10x. So where is the slope equal to negative 3? Well, that's when x is 3/10. Now again, you have to plug that into your function to get the y value to find the point. And that would be 9 over 100 times 5, so 45 over 100. I guess you could simplify that. So that point would be 3/10, negative 9 over 20. Not too bad. Okay, this one might be easier. Ooh, tough one. That looks like it's going to be where x is 0. If you plug in 0 to your function, you get a 0 back out. So that's telling us that this parabola has its vertex at 0, 0, because that's where this slope is 0. Alright, and then last one here. Where is negative 10x equal to 2/3? So divide by negative 10 or multiply by 1 over 10. So that's 2 over 30 or 1 over 15. I guess that would be negative 2, wouldn't it? Okay. Plug that into your function. So you get negative 1 over 15, negative 1 over 45. Alright, there we go. Example 6 is good practice. We'll finish up with this one. Rewriting is really important if you want to use the power rule, okay? Rewriting is very important if you want to use the power rule. It has to be in this kind of form, and n has to be a real number. So let's rewrite these. So we have 5 halves, x to the negative square root of 2. Now it's in that form, ax to the n power. So now we are going to multiply. So we get negative 5 halves times the square root of 2 times x to the negative square root of 2 minus 1. There we go. Nothing wrong with that. The next one. This is 4 over 8x cubed. Okay, it might help us to rewrite it as 1/2 x to the negative 3. So now we have negative 3 halves x, subtract 1 from the power to the negative 4th power. And if you really want to go crazy, you could rewrite it like this. Okay, but you don't have to. The next one here, I'm going to rewrite this. Now I have t to the first over t to the 1/2. Another way to write that is t to the 1/2 power. So I have 7/3. I'm going to be taking the derivative with respect to t of 7/3 times t to the 1/2. Rewriting that makes it a lot easier. Alright, so I have 7 over 6 t to the negative 1/2. And again, if you feel like rewriting it, which you don't have to, that would be 7 over 6 times the square root of t. Alright, last one. Negative 2. Alright, so instead of having that as negative 2, I'm going to bring it up and rewrite it as 2. So that's 6 times 9m squared, or 54m squared. Look how much easier that problem is when we rewrote it, 54m squared. So the derivative of that, 2 times 54, 108, m to the first. There you go. It's a great set of information there. Have a good day.